Hello, college algebra students. So today, now we'll take a look at how do we solve systems of nonlinear equations in two variables. So far, we have been looking at how to solve systems of linear equations, even in two variables and three variables. Also, we looked at various other things. So now what we're going to do is we're going to take a look at how do we solve nonlinear equations. So when you have linear equations, and then we try to look at things geometrically speaking, right? What you have is you have two lines, and they are going to intersect, or they're not going to intersect, right? So you're going to have two lines. So then you are going to have a few cases there. So either they are going to intersect. Here is a case where they are not intersecting. If you take a look at these two lines, right, they're intersecting at only one point. Or if you take a look at this particular line, this is actually intersecting infinitely many points. It's basically one on top of another. So you have infinitely many solutions, and then you have no solutions, and you have only one solutions, right? So that's all you have when you deal with the linear equations. Linear equations of two variables. Now, how do you work with nonlinear equations? So when you have nonlinear equations, now if you try to look at them geometrically, then you may have a parabola, right, which is represented by an equations like this, right? And then you may have a line. So we have one linear equation, one non-linear equation, or you may have you may have two circles. You may have a circle one, and then you have another circle, so or another ellipse in here, right? So again, this is a circle. This is a circle. Excuse me here. This is a circle, and this is an ellipse, and they intersect, and here you see they're intersecting at two particular points there. Or you may have a parabola, and then intersecting with a circle. Again, you may have two in there. Or you may have a parabola and a circle. It might be intersecting, or an ellipse like this, right? Then you have four intersection points. So now things are going to be a little bit more mathematically complex when we work with nonlinear equations. So let's take a look at some of these simple equations and see how do we solve them. There are many methods. One of the things that we often use is the substitution method, and if it doesn't work, we'll try to look at other things, right? So let's take a look at how do we solve nonlinear systems using a substitution method. All right, so let me take a look. All right, so if I have two equations here, as you see, right, and as I said earlier, this looks like a parabola, and this looks like a line, right? So we have two equations. So it's going to be in one of these cases. It could be either this, it could be either this, or this, or this, right? So you may have a case where no solutions, where there's only one solution, or two solutions there. No problem. So let's see how do we solve that. In generally, the way that we solve them is the following. In substitution method, you try to substitute one of these variables from one equation, right? Usually we try to simplify one of these variables, right? And then plug that back into this nonlinear equation here. So this equation is nonlinear. The reason because I have x squared in here. So that's what we're going to do, right? So we're going to, in this particular case, we're going to simplify one variable in terms of the other using this one, and then plug it back into this one. So let's see how do I do that. So if you take a look from this equation, you would agree that as a step one, I'm going to write y in terms of x, right? So if I write y in terms of x, you would agree with me that 4x minus y is equal to minus 1 is going to give me y is equal to 4x plus 1. So basically, I'm moving my y on the other side, that becomes a positive y, and I'm moving negative 1 on this side, that becomes a positive 1, and that's what I'm going to have. Now what I'm going to do is a substitution step. So that is a substitution step. So what is the substitution step? This, I'm going to plug this back into my the first equation, the parabolic equation, right, or quadratic equation. When I do that, what's going to happen is the following. You would see that this is going to be x squared is going to remain as is, and then y is going to become 4x plus 1, and then -1 remains as is. And as you see now here that I can cancel the 1 and 1. So the equation that I have here is x squared minus 4x is equal to 0. And then if I factor the x out, I'm going to have x times x minus 4 is equal to 0. And therefore the solutions are, in this particular one, x equal to 0, comma 4. In generally, you would double check, see if these answers make any sense or not. I'll let you go and check, see if any of the solutions make sense, or if none of them make sense, or one of them makes sense, and so on. So in this case, if you take a look, I have x here, by the way. Oh, by the way, if we also forget, I also need to find the y also, which I did not do it. Let's quickly do the y. So if we try to do the y, now here we have the x value, right? Let's plug it back into any equations. It should work for both equations. So I'm going to plug it back into the y, the first equation, parabolic equation, and that's going to give me 0 squared equals y minus 1. That tells me y is equal to 1. So when x is equal to 0, y is equal to 1 is what I'm getting. When x is equal to 4, then I'm going to have 4 squared, which is 16, equals y minus 1. That tells me that y is equal to 17. And that is how we would solve these equations in here. That's how you would solve. Again, in this case, you can go back and double check, see if these values work for this particular equation, and see if it doesn't work, then you can throw them out. In this particular case, both of them is going to work. So therefore, the solution for our problem is x equals 0, y is equal to 1. That means you have 0, 1, and x equals 4, and y is equal to 17. That means we have 4, 17. Or these are the two solutions for this particular problem. Let's take a look at how do we solve another problem very similar to this. So here we have another problem. Again, we're going to use the substitution method again. And here we also have one straight line. That's a linear equation, so it's a straight line. But we have a circle. We have a circle of radius square root of 5, and then centered at 1 and 1, right? So what we have is, if I try to graph it, we have a circle, and then we have a line, and we have a line. So you may have, three possible scenarios. If the line is over here, it will not intersect at all. But if the line is over here or here, then it will intersect only at 1 point, right? Only 1 point. If it's over here, it will intersect at only 1 point. Or if it is over here, it may intersect at more than 1 point. So these are again three possible scenarios for this. So let's see how do we solve this. So again, just like we did earlier, we're going to, from this equation, we're going to write one variable in terms of the other variable, and then we're going to plug it back into this equation of a circle, and then we're going to solve it. So let's see how do I do that. Now what I'm going to do here, the first equation tells me, the first equation is x plus 2y is equal to 0. So the first equation tells me that x is equal to negative 2y, and I'm going to plug it back into my second equation. That is a substitution step, right? So if I plug this into the second equation, what I'm going to have is I'm going to have a negative 2y, negative 1, the whole square. Basically, I'm plugging this back in over here. And then I would have y minus 1, the whole square, is equal to 5. If I simplify this furthermore, if I do the foiling on this, I would have 4y squared plus 4y, and then plus 1, plus I would have y squared minus 2y plus 1 is equal to 5. And if I simplify this, I would have 5y squared minus 2y. This is 1 plus 1 is 2, and then there is a minus 5. If I bring it in, it's going to be minus 3 equal to 0. And again, you can use the quadratic formula, or you can factor it out anyway, whichever is convenient for you. You can do that. If you factor this one out, you will see that the factoring is going to be 5y. I'm going to say 5y plus 3, and y minus 1. That's a 5y minus 3y No, it doesn't work like that. So I'm going to change it back. So it's going, this is going to be +1 and this is going to be -3 is equal to 0, right? So you can work with that. And if you solve this, right, if you solve this, this is going to give you y to be 3/5 and -1. And again, now we have to plug it back into the x and see what the values of x's are. So if I do that, let me just make a box in here. Let me change the color. So now if I plug it in, when y is equal to 3/5, right? X is going to be -2 times 3/5, which is -6/5. And when you plug in y is equal to -1, x is going to be -2 times -1, which is +2. So therefore, the solutions are, the possible solutions are -6/5, comma 3/5, and 2, comma -1. Again, you have to go back and double check to see if these numbers works out. I'll let you do that, and that's how we solve these nonlinear equations using substitution method. Let's take a look at how do we solve by the addition method. So the idea is very similar, like we did earlier. So here I have two equations, right? Here I have two equations. So we're going to add and cancel things. To do that, what I'm going to do, I need I'm going to eliminate either x variable or y variable. So if you want to eliminate the x variable, I want the coefficients of the x and the coefficient of the x from the equation 1 and the equation 2 have to be exactly the same. To do that, what I'm going to do in this particular case, I would multiply this equation by 4 and this equation by 3. So when I do that, I have 12 here and 12 here. I cannot just multiply this one. If you have to multiply, I have to multiply with this entire equation, right? I have to multiply this 3 with the entire equation. But anyway, when we do that, then I would have a same coefficient for both the for x's for in both x. I have the same coefficient for x squared in both of these equations, so I can cancel them out by adding easily, right? So let's quickly, or subtract easily. Let's quickly see how do we do that. So now I'm going to call this the equation number 1, and I'm going to call this the equation number 2. What I'm going to do here is I'm going to multiply the equation number 1 with the 4. That's going to give me 12x squared plus 8y squared equals 140. I'm going to multiply the second equation by 3. When I do that, that is going to give me again 12x squared. That's what I want, right? And then plus 9y squared. And then it's going to give me 3 times 48, which is 144. Now I'm going to add, but before I add, I'm going to change the signs. I'm going to change this to entire sign of the equation. I'm going to flip it. Here it's a positive became negative, positive became negative, positive became negative, right? So now if I add these two equations, ladies and gentlemen, and these two gets cancelled, I would have a negative y squared in here, and I would have -4 here. So this tells me that y squared is equal to 4. So therefore, y is equal to +2 or -2 are two possible solutions. So now let's see what happens. We found the y value. Let's try to figure out the x value. We can use either of these equations to do that, but I'm going to use the equation number 1 to do that. The equation number 1 is 3x squared plus 2y squared is equal to 35. When I plug in y squared is equal to 4, that's going to give me 3x squared plus 2 times 8 is equal to 35, right? By the way, this when I say y squared is equal to 4, that takes care of both possibilities, right? That takes care of both possibilities. So now here I'm going to have 3x squared is equal to 35 minus 16, which is 27. So 3x squared is 27. Therefore, I have x squared to be 9. So therefore, x is equal to plus or minus 3. So we have two possibilities again for x. Let me write it down. So we have positive 3 and negative 3. And so therefore, the possible solutions are, in this case, 2 and sorry, no, it should be x's, right? So the possible solutions are, in this case, x's are 3 and y could be 2. and x is 3, and y could be -2, and x is -3, y could be +2, and x is -3, and y could be -2. So you have 4 possible solutions. Again, geometrically speaking, what we have here is this is an ellipse, this is an ellipse, and this is also an ellipse. So therefore, you see that when we try to graph it, so here is one ellipse, and here is another ellipse, here is another ellipse, and you see that we have 4 possible points of intersection. 1, 2. So here we have 1, 2, 3, and 4. So those are the 4 possible intersections, and that's what we have in this particular case. So we have 4 solutions for that. All right, so how do we solve this problem? Again, so what we have here is we have a linear equation, we have a quadratic, I'm sorry, we have a parabola, right? A quadratic equation, parabola, and then we have a circle, right? So again, if you look at geometrically, you have a parabola there and you have a circle. So you may have a case like this that doesn't look like a circle, assume it's a circle, or you may have a case like this, right? Or you may have you may have a case like this. So you may have 2 solutions, you may have 4 solutions, or you may have 1 solutions, or you may have no solutions at all, right? So there are 4 possibilities, right? There are 4. Here's the case where there's no solutions. Here's the case where we have no solutions, and here's the case where we have only 1 solution, and here's the case we have 2 solutions, and here's the case we have 4 solutions. So these are 4 possibilities. So let's see how many we get in this particular one. So again, we're going to use addition method for this one. You can also use a substitution method too, but we're going to use addition method and see how do we do that. So for that, what I'm going to do, I'm going to rewrite this equation into some sort of this form. What do I mean by that? I'm going to move this x squared on that side. When I do that, the first equation, the parabolic equation, is going to become -x squared plus y is equal to 5. The second equation I'm going to keep as is. That's a plus y squared plus x squared plus y squared is equal to 25. Now, when I add these 2 equations, ladies and gentlemen, what I have is, you would agree with me that these 2's are going to go away. And then I'm going to have y squared plus y is equal to 30. And this tells me y squared plus y minus 30 is equal to 0. And if I factor this out, that's going to give me y plus 6 times y minus 5 equal to 0. That means y is equal to -6 and +5. Again, here you may have to double check to see which one makes sense, which one does not make sense, and so on. So here y is equal to -6 and y is equal to 5. So let's take a look at in each case what happens. When y is equal to -6, let's plug it back into the parabolic equation. I'm going to have -6 is equal to x squared plus 5. And if I solve for x squared, you see that I'm going to get a -11. You know that that is impossible, right? You know that this is not possible because this is not possible because x squared never become negative. So therefore, that is not going to give you any solutions there. So this is not a so this is not going to work out for us, right? So the y is equal to -6 is not a solution. So let's take a look at the other value, which is y is equal to 5. When I plug it into my first equation, it doesn't matter, you can plug it into any equations, by the way. When I plug it into my first equation, it's going to give me that 5 is equal to x squared plus 5. That tells me that x squared is equal to 0. That tells me x equals 0. So the solution that we have here, so it seems we have only one solution, and that one solution is x is equal to 0 and y is equal to 5. So here we have a case of this particular one right there. So here we have this particular one, and they're intersecting at only one point. And that's how we solve these nonlinear equations. So in the next session, we're going to take a look at how do we solve inequalities and by graphing them. And then we're going to take a look at, and then the section after, we're going to take a look at linear optimization. All right, I will stop it right here. I will see you all in the next section.